Hello, everyone. All right, so we're going to begin Unit 2 by talking about relations versus functions. So we have a lot of vocabulary that we're going to have to cover and be aware of in order for us to really be successful in this unit. So the first one we're going to take a look at is called an ordered pair. So an ordered pair is just another way of saying a coordinate. So it's going to be written just as we have seen before, just as an x comma y with parentheses. So your x coordinate represents your horizontal placement. So it's going to be along the x axis, and then your y coordinate represents your vertical placement on the y axis. So whenever we're looking at all this data in terms of graphs and whatnot, we're looking at what we call a relation. So a relation is what we call a set of ordered pairs. So is a set of coordinates. So a function is going to be kind of a subset of a relation. So a relation in which each element of the domain is paired with exactly one element of the range. So we're going to be talking more specifically about what a function is, what it looks like, and whatnot here in a little bit. So mapping is going to be a different illustration in which you may or may not have seen before, but we'll get to a visual of what that looks like later on. And then we're going to be talking about domain and range. So your domain refers to all the x values, which we also call input values. And then your range is going to refer to all the output values, which are your y values. Okay. And then we also touch on your independent and dependent variables every now and then. So just a general rule of thumb, your independent variable is going to be your x values, whereas your dependent variable, these are going to be your y values. So whenever we're looking at representations of relations and functions, we're going to have these four different representations. So we have ordered pairs or coordinates. We also look at tables, we look at graphs, and then we look at mapping. So mapping is what's probably going to be new for some of you, or all of you, who knows, maybe. But we're really going to be looking at this information down here to determine whether a relation represents a function. So a function is going to be a relation in which each element of the domain is paired with exactly one element of the range. So what all that jargon means is we just want to see if an x value is going to repeat. So whenever we're looking at all four of these representations, there's certain ways in which we can determine if it's a function. So for the ordered pairs, tables, and mapping, for all three of these, we just want to see if the x value is going to repeat. If it does not repeat, it is a function. If it does repeat, it's not a function. Now for a graph, we're going to look at what we call the vertical line test, or we can abbreviate it as the VLT. So if it passes the vertical line test, it's a function. If it fails the vertical line test, it's not a function. So a lot of these questions on 2A are going to ask, does this relation represent a function? If it does, why? If it does not, why? So a lot of this lesson is also going to focus on the explanation part. So there is going to be some writing. So another big question that I get asked a lot is, does it matter if the y value repeats? And in actuality, no, it does not matter. So the y value can repeat as much as it wants. It's really just looking at the x values. All right, so now we're just going to kind of look at some examples here. So these are just models up here. So these are actually examples down here. So we want to determine whether any of these sets represent a function or not a function and determine the reasoning. All right, so if I look at the first set of ordered pairs, remember we only look at the x values. So we have 0, 1, 2, and 3. So none of these values repeat. Therefore, yes, it is a function. Then the reasoning, no x value repeats. So that's all it is. Yes or no, and why. So looking at the second set here, so we're looking at 1, 3, 0, and 3. Now if you notice, 3 here occurs in more than one spot. So because the x value repeats, no, this is not a function because x equals 3 repeats. So notice how I'm very explicit right here. I'm actually telling you which value is repeating. So whenever I'm looking for an explanation, I am expecting you to say which value repeats, not just saying x repeats. You have to say which one. So if you also kind of refer back to the first one that we did over here in purple, notice how the y value repeats, but it's still a function. So remember, the y values, it doesn't matter. We are only looking at the x values. Okay, so those are for the ordered pairs. Now we're going to take a look at the tables. So once again, looking at the x values only, so we have -1, 0, 1, and 2. Those are all different. So this one is a function. So no x value repeats. All right, looking at the second table over here. So we have 1, 2, 1, 2. So we actually have a couple different sets. So we have one that repeats. We also have 2 that repeats. So this one's really not a function. So not a function. X equals 1 and x equals 2 repeats. So there's actually more than one reason why this one's not a function. All right, so now we're going to take a look at let's go to mapping so we can kind of stay consistent in what we're looking for. So with mapping, your x values are in the left oval or ellipse, and your y values are on the right oval. So I'm going to look over here. So we have 1, 2, and 4. Nothing repeats. You only have one arrow going to each value. So this one is a function. So if we look at the next mapping over here, so we have our x's and our y's. So they're not going to be labeled. You don't have to label them, just so you're aware the x's are on the left side. So if you notice, we actually have 2 arrows stemming from this 6 right here. So that's going to tell you that this is not a function, that x equals 6 repeats. Okay, so just some little clarification for you guys, just in case. So over here, if I were to write this first one as a coordinate, this would be 1, 5. Then my next coordinate would be 2, 4. My next coordinate would be 4, 1. So those are all of those coordinates. And then over here on the right side, so I would have 6, 9, 6, 0, 3, 0, and 8, 7. So those arrows really tell us what that x value is mapping to, what corresponding y value it has. So because this 6 has 2 arrows stemming from it, it repeats. Therefore, it's not a function. All right, so now looking over here at graphing. So graphing, we're going to do what we call the vertical line test. So what I'm going to do, because technology is so amazing, I'm literally just going to draw a vertical line and make it a little bit more obvious. So what I want to do is literally just take this vertical line and see if that function, or alleged function, the relation, I want to see if this relation is going to hit my vertical line at more than one point at any time. So if you notice, only one point along this relation will ever hit the vertical line. So because of that, that means, let's change that. So yes, this is a function, and for the reason you could say passes the vertical line test. All right, so looking over here. So now if I do the vertical line test over here, now let's say I leave it right here. So if you notice, my vertical line hits the red relation here, here, and here. So because it hits it more than once at a time, that automatically means it fails, which means this is not a function. And you could just say fails vertical line test. So keep in mind the vertical line test only works for graphs. It does not apply to the other three different representations. All right, so more vertical line test practice over here. So I gave you these three different relations on the graph, and we want to determine if these are going to be functions or not. So looking at the blue line, so let's actually take the line from up here. So if you look, this is going to seem kind of weird. Well, the blue line, it actually hits my line literally at every single point. It literally hits everywhere. So because of that, ironically, the vertical line fails the vertical line test. So it's not a function. The reason it fails the vertical line test. I always find it ironic that a vertical line fails the vertical line test. Everything's fine. Okay. So now I'm going to look at the black circle. So let's take this line. So I don't even have to get very far. So even just right here, it hits it at more than one spot, therefore it fails. Remember, it can only hit it one place at a time. So it does not pass, fails vertical line test. Doesn't even have to be a complete sentence, like literally just fails VLT. Okay, now this red little S looking thing over here, whatever you want to call it. So if I put it in this spot here, for example, it really fails because it hits it at 3 spots. However, let's say I draw another line over here. Well, it would still fail. So you only need one spot in the relation for it to fail. If it fails in one spot, automatically it's not a function. So not a function. Nope, gotta keep up the pattern. Fails vertical line test. Boom. All right. So now we're going to move on to mapping. So mapping is what's probably new. So just as mentioned before, it has a little bit of a few things that we got to go over. So whenever you're doing mapping, it works out of 2 different distinct ovals. So whenever you're writing your values, the X values go in the left oval, and they must be in order from least to greatest with no repeating values. So the X values are in the left oval. And then the Y values are in the right oval. So same thing, everything has to be written from least to greatest with no repeating values. Okay. So whenever you're connecting the values from the different ovals, you want to use arrows. All right, so given these ordered pairs, our coordinates, we want to actually create a map. So I'm just going to draw 2 ovals. It doesn't matter. Press and hold, and it will automatically populate. All right, so I'm going to copy it. Nope. There we go. So it's the same size and everything, and it lines up. All right, doesn't matter what the colors are. All right, so the key thing, hello, least to greatest, no repeating values. So I'm going to look at just the X values first. So I have -1, 0, 5, 4, -4. So the smallest of those values is -4. So I got to start with -4. So I'm going to kind of keep a checklist. I'm going to cross it off. So my next value is -1. So I'm going to write that, done. Then I have 0, 4, and 5. Okay, so those are done. So I'm going to get rid of all that so I can see my values. Now I'm looking at the Y values for the right oval. So I have 3, 3, 6, 5, 9. So I'm going to go back to purple. So the smallest of those, we have 3. So notice how we have it in 2 different places, but we only write it one time. So our next value, we have 5, then 6, then 9. Thankfully, I remember the order of numbers. Okay. So another thing, make sure you're using your entire oval I've seen some people like scrunch up all their numbers like in the very top, like please don't. Use your entire oval, especially because you have technology. Okay. So now I'm going to start using arrows to actually map the different values. So -4 is going to go to 9. So I'm going to take -4 and it's going to map all the way down to 9. So there's a little arrow. All right, so my next one, I have -1, so -1 maps to 3. So it's going to go up here. Okay, 0 goes to 3. So I have another line going up here. All right, and then I have 4 that maps to 5. And then 5 maps to 6. Hello. All right, so every one of these numbers should have some form of arrow either stemming from it or going to it. You should never have a number that's just kind of standing out there, standing alone. All right, so now we want to determine if the function's a relation. So if you look, do any of these x values in the left oval, do any of them have more than one arrow? The answer is no. So that means this, hello, no, this is a function. No x value repeats. Okay, so if you notice, we do have 2 arrows going to the 3, but remember the y values, they can repeat. It's just the x values that cannot repeat. Okay, now example 2. So I would say pause here and actually try this one on your own. Okay. So once again, x values on the left, y values on the right. Least to greatest, no repeating values. So I'm going to start with all my x values. So 2, 6, 5, -4, and +2. All right, so start with -4. So that one's done. The next value is 2. So notice how it appears twice. I'm only going to write it once. Then we have 5 and 6. Okay, so I'm done with those. I'm going to get rid of all those markings. All right, now I'm looking at the y values. So we have 2, -2, 6, 5, and 9. So once again, least to greatest, no repeating values. So smallest value is -2. Done. +2. Done. Then 5, 6, and 9. Okay. Now I can start drawing my arrows. All right, so -4, it's going to map to +5. So that coordinate's done. So, I mean, it doesn't really matter where you start or how you do these. So now let's say I'll do 2, 2. So that one's done. So let's knock out 5, 6. That one also goes over here. Done. 2, 9, which goes down there. So that one's done. And then we have 6, -2. I don't know why I went in this order. Everything's fine. Boom. Okay, so some of your maps are going to look very elegant and very nice, and then some are going to look like this, a hot mess. So some of these are going to have arrows going literally everywhere, which is okay. So now we need to determine if this is going to be a function. So once again, look at your left oval, and you want to see if you have more than one arrow coming from any of those values. So if you look at -4, we only have one arrow. If you look at 2, we have 2 arrows. So automatically right there, it's not a function. Not a function. The reason x = 2 repeats.